That's much better. Okay, good afternoon and welcome to the Cradle of Aviation Museum. My name is Catherine Gonzalez and I am the Education Director here at the museum. And we are so excited that you guys have joined us for our Mars Day celebration. Sorry. Today, the Cradle and National Geographic Live present Kobie Boykins. He's a mechanical engineer from NASA and the Jet Propulsion Lab. Kobie has an I can tell that you're going to have fun already. Kobie has had an experience that very few people have had. He got to watch a rocket blast off, and in that rocket was a vehicle that he helped design and build. After a long journey through space, this vehicle landed safely on Mars and started to explore the red planet, taking pictures and communicating to Earth. Now, what's the name of that vehicle? The Mars Rover. Very good. Excellent. So, the Mars Rover lands on Mars, and Kobie Boykins was a big help in constructing those vehicles, and he's going to tell you a little bit more about that today. Not only is Kobie a successful space engineer, but his energy and his enthusiasm make him a wonderful voice for the future of our space program. So please join me in welcoming Kobie Boykins.
All right. This is a good-looking group. I'm not going to make the same joke about being underdressed, but All right. How are you guys doing this afternoon? This afternoon. How you guys doing? That sucks. All right. Can we do that a little bit louder? Oh no, we're going to do it again. Okay, hold on. How are you guys doing this afternoon? Yeah. All right. That was awesome. Thank you guys for that. I want to get a little bit of energy going. You know, it's a little bit afternoon. I know some of you guys had lunch, and I don't want anybody to fall asleep, because that would be terrible, right? All right, so today what we're going to do is we're going to do an exploration. For the next 3 hours or so, I'm going to stand up here and I'm going to give you guys a dissertation on what it is to work on Mars. Yeah. And there's going to be a test. I've given all of your teachers a test, a quiz, and I'm serious, so you guys better know. Okay, if you guys all fell for that, I'm just kidding. There's no test. This is all about having some fun, all right? All right, okay, now I'm going to get you guys all back. Okay, so let's start off, and if we can bring the lights down a little bit, that'd be great. I'm going to tell you guys a little bit about myself and my background. So my name is Kobie Boykins. I'm a mechanical engineer. I actually was born in Omaha, Nebraska. So I grew up in the middle of the country, and more or less in the middle of a cornfield, so right outside of Omaha. And one of the things that's nice about growing up in the middle of the country where you don't have a lot of light spillage like you guys have here in New York is that you can see the night sky. This is an image of me in the clean room, and behind me is the Curiosity rover, and it's just sort of nice to sort of show that, hey, I actually am one of the people that actually gets to work, design, build, and put these vehicles together. But my love of science started off when I was probably in 5th grade. Probably a little earlier, I was a Star Trek fan. So anybody that's watched some of the new Star Trek movies, or a Star Wars fan, definitely a Star Wars fan. Next movie was pretty good, right? Right? Okay. But let's talk, oh, I did see this little trailer. Let's talk about space for a little bit. So one of the most amazing things that we have as human beings is we're actually able to take images of what's going on in our solar system, in our galaxy, and in our universe. And for me, looking up at the night sky and seeing nebula, seeing the collision of stars, and getting images like this particular picture from the Cassini spacecraft of Saturn, were the things that really drove me into wanting to work in space exploration. I'm going to sit on this image for just a little bit. This is the image from the Cassini spacecraft of Saturn. Cassini just ended its voyage. Right? And the first thing I got to see when I got to the Jet Propulsion Laboratory as a young engineer was that spacecraft. So I actually got to see that spacecraft before it was launched, 7 years on the way to Saturn, and then another 5 years of exploration before we actually ran it into the surface, the upper clouds, and it burned up on the way in to do the investigation. Crossing the plane of the rings, something like 23 or 24 times, can't remember the exact number, right? But amazing images from our planetary bodies taken by things that were built by human beings. And that's what I wanted to be part of as a kid. And I got that chance. This is my favorite image that's been taken from the Hubble Space Telescope. This is called Hubble's Deep Wide Field. We actually looked at a part in sky that had nothing. If you look at 2 millimeters by 2 millimeters, if you put your fingers together in that little square that's made by your fingers, that's approximately 2 millimeters by 2 millimeters. We looked at a section of the sky that's that small, and we looked at it for 2 weeks, and we get this image. Everything you see in this image is not a star that we know in our own galaxy, but a cluster of billions of stars. Every speck of light in this image is another galaxy. Let me show it to you a different way. So instead of just looking at the image, let's fly through the image. So now, you're flying at something like 300 light years a second. You're flying faster than the speed of light. The oldest speck of light in this image is 14.3 billion years old. That's the beginning of our universe. We're looking at history. We're looking back at time in this image. Every one of those another galaxy. You can see spiral galaxies like our own. I'll point one out. There's a spiral galaxy. That looks very much similar to the Milky Way, but that's tens of hundreds of millions of light years away from us. These are the types of things this image makes me and reinvigorates my exploration, my need to go out and explore and understand what's going on in space. This orbiter, Mars Reconnaissance Orbiter, has a very, very good camera. The camera can resolve something that's about 20 centimeters, so we can actually see our hardware on the surface of Mars. So we'll highlight that for you guys. We'll zoom in on where the rover landed. You can see the soil where it's been disrupted from the downward-looking thrusters. We'll zoom back up. The next thing we're going to do is we're going to go over to where the parachute is. So every once in a while, we'll look back at this area, and we'll see which way the parachute's blowing, and we'll know which way the wind is blowing on the surface of Mars. We'll go over and see where the heat shield collided with the surface. We get some interesting science out of there. I'll show you a video in just a second. And the last one is we designed that descent stage to fly away from the rover about 600 meters. So when you zoom back out, that's the descent stage and where it crashed into the surface. And that point from there to there is 608 meters. Pretty good job. So the next image is where we went. We went to the Gale Crater, which you saw we just zoomed in on. We went to the Gale Crater to climb up this mountain with the rover called Mount Sharp. Mount Sharp's a 5.5 kilometer high mountain. You can see it's sort of compared to some of the mountains that we have here in the United States, and not just in the United States, but here on Earth. The next video is something very interesting. We didn't think we were going to capture this. Remember I told you we have that downward-looking camera? Well, that downward-looking camera caught something. You see our heat shield coming in, and we caught this collision with the surface of Mars with our back shell, our heat shield. And with that collision, we can actually tell a lot about the soil. We can tell its impact properties. We can learn angle of repose, which is very interesting for how much we can climb. We can learn a little bit about the properties of how much compaction there is in this area on the surface of Mars. Then we did something that all of you guys know how to do. We started learning how to take selfies. So we took the first selfie of the rover, which was sort of a cruddy, bad selfie. You can see it's just shadows. Not so good. Then we got this image. Okay, some of you guys are awake, I guess. Yeah, this isn't real. Not real. Optimus Prime did not come and talk to the rover, although that would be awesome. I would totally take that, but Optimus Prime didn't come see us. But I thought it was cool, and I just wanted to make sure everybody was still awake. But we got really good at taking selfies. So now we took the arm, and we looked down the barrel of the laser. Anybody think that was a bad idea? Yeah, we turned off the laser. But so we took this selfie. And then we got really, really good at selfies. We got something like this. So this was taken over the last month. This particular selfie was taken over the last month. It's probably one of the highest resolution selfies that we've taken. It's awesome. You guys can go download it. It's super cool. But you can see that we actually put the arm off and we take an image back of the rover so you can see our whole rover on the surface of Mars. You can see Mount Sharp poking out in the background up here as we're trying to climb up Mount Sharp. One of the other things that's interesting about being one of the team members is that we get to design the hardware. Right? And here's the wheels. And the wheels were designed by Sean Haggard. He worked in the group that I led. And one of the things is he came up with this idea to build a wheel that said JPL. He said, ooh, wouldn't it be cool to stamp JPL on the surface of Mars? So as we were driving around the surface of Mars, it would say JPL, JPL, JPL. And that if maybe sometime in later somebody went up there and they're like, oh, somebody from JPL was here. That was cool. So that was our idea. Well, we got told that we couldn't do that. So we had to change the wheel design. So we had a design team meeting. We got together. We came up with different ideas. I said, hey, let's put chicken feet on there. Stupid idea. That got shut down pretty quickly. But we did come up with an interesting idea. Now remember, I told you we wanted to just make it say JPL. And you know, we got told no. So we sort of said, okay, how smart are the people that told us no? So we put this thing on we put this feature on the wheels right there. You look at it, it looks like that. Anybody in the Scouts get their Morse code badge?
Oh.
So we were told we couldn't put JPL on there, but JPL and Morse code's okay. So now, on the surface of Mars, JPL, JPL. Okay, it might just be funny for me, but it's really cool. So the wheels do say JPL. Now I'm going to point out one other thing in this image, and I'm going to tell one more story. I think we have enough time for at least one more story. Most people in this particular image, which is a real image from the surface of Mars, will miss something. Now the JPL part isn't real, I put that in there, but they will miss something in this particular image. What they will miss is that. You see the light coming through the wheel? Yeah. That's not supposed to happen. So let's start an investigation. Oh. We started looking at our wheels to see what the surface of Mars was doing. And we started punching holes in our wheels. We were driving over rocks that were very sharp. They were causing damage to occur to our wheels that we never would have expected to happen. Let me zoom in on that hole for you. Right? We called that the Marvin the Martian hole. Right? It looked like one of the Martians took a ray gun and shot it at us. Right? And we were really scared about this. The holes weren't as scary as these cracks. Remember I told you this was made out of aluminum. Aluminum has a thing which is terrible for aluminum. It propagates cracks. Like a can, if you start a crack in a can, you can open up the soda can. Well, same thing happens with our wheels. So this crack is going to propagate all the way across the wheel. We were getting really freaked out about that. So we started doing some testing. So we did a lot of testing. Here's another picture from Mars. You can see us. We even picked up a rock. See that? Stuck in the wheel. So we did some testing. And we wanted to fail the wheel. We wanted to understand how it's going to fail. So you can see pseudo good wheel over there, totally broken wheel. This is what's going to happen to our wheels on Mars after some period of time. We're going to destroy it, and it's going to look like that. Excuse me. And so we had to figure out how to design around that and how to make it work. One of the things that we did is we started driving the rover backwards. And the other thing is we started trying not to drive over rocks. So we added some new rules to the rover planners to say, hey, that rock is too big for us to drive over. We have to drive around it. And so now we've added software that looks at the rocks and then helps us guide the rover around rocks that could be detrimental to the wheels on the surface of Mars. And here's one of the images. This is from about 3 or 4 months ago. And you can see we've started to do what we did a lot of testing. One of the things that we did is what we call grousers. Those pieces that go across the wheel are called grousers. You see one of the grousers is broken. Once we break 5 grousers on one wheel, we have about 80% of the life is gone. We have 20% of the life left. That's about the number that we calculated. So we have a laser on this vehicle. Everybody thinks the laser does this, which would be cool. It doesn't. This is what the laser does. Makes little holes on the surface. But let me show you that a different way so it makes a little bit more sense. So in this video, what you're going to see is you're going to see a rock. Normal rock on the surface of Mars. I'm going to take everything that's not the rock away when we're shooting a laser at it. You see a little blue glow in the middle? That's what we look at. When we look at that, that's a gas or a plasma. We look at that, we can actually tell the elemental chemical composition of that rock. So not to be outdone by Spirit and Opportunity, Curiosity found a meteorite on the surface. But unlike Spirit and Opportunity, we had the right instrumentation to tell where it's from. So we can shoot that with the laser and look at the gas, right? This didn't come from one of the 4 rocky planets. Iron rich, very iron rich, probably came from the asteroid belt. Can't tell exactly, but we know it's from the asteroid belt. Here's some cool images of us doing some sampling. Remember I told this is the first time we've actually sampled robotically. So you'll see this video. That's the first hole that we made on the surface of Mars. That very first hole, the very first drill hole that we took on the surface of Mars, told us that if life started on Mars, it would be able to be sustained. All the building blocks for life were in that first sample that we took. So we actually did exactly what we sent the rover to do. Verify that if life started on Mars, it would be sustainable. All the building blocks for life are there. So that question answered. The life question, not answered yet, but That question answered. I'm going to quickly go through a couple images that I just think are beautiful of the surface of Mars. Just really cool. This looks like shale rock. If anybody is into geology, it looks like shale rock. And in shale rock here on Earth, we find oil. That's what they look for to search for oil, and the oil lives within the areas of the shale. One of the places. Here's all the places that we've been on the surface. You can see we landed right there, and we've driven to there. This is Mount Sharp. We've named some other areas. And the reason that I put this image in there is really for this next video, and hopefully the video will work. Let's see.
When the Curiosity rover climbed a ridge
this is our
and the
chief
skies cleared
scientist.
up during Martian winter,
I've never played this video in a
he had the
presentation
chance
before.
to take this
I'll talk
amazing
over it a little bit.
panorama.
But this is the
I'm really
latest
glad we
panorama
did.
that we've done. And in this panorama,
Curiosity is inside Gale Crater, a huge basin made by an impactor about 3.8 billion years ago.
you see some of this, how amazing the
Mountains
cameras
across the crater
on the
floor
surface.
are actually the northern rim of the crater. They rise over a mile above the rover.
As we go over here, we're actually going up across the
It's so
panorama in a
clear
video.
when we took this image that you can even see a hill outside the crater that is 50 miles away.
So from where we are, I'm going to zoom forward, but that's 50 miles away. Isn't that
I
cool?
love how you...
It's a beautiful image. You guys can download it. So now I'm going to talk a little bit about what's next. What's next for us in exploration. So the next rover that we're going to do on Mars is called Mars 2020. I told you that earlier. This is an artist concept of it. That's what it looks like. It looks very close to Curiosity. It's the same size. It's the same shape. Very different science suite. So the investigations that we're going to do are a little different. And you see that we've changed the wheels. We've changed the wheel design, made it a little thicker so that we won't have the problems that we had on Curiosity. Here's some of the sciences instruments that we have. I'm going to point out one of them for you because it's probably one. Oh, I should point out two. I'll tell you guys something I didn't tell the first group. So, my favorite instrument, MOXIE, the Mars Oxidation Experiment. What does it do? The Mars Oxidation Experiment takes carbon dioxide from the atmosphere of Mars, sucks it inside the vehicle, does some stuff, and spits out 99.6% pure oxygen. Why would we do that? Because we can, yes. No, because if we want human beings to go to the surface of Mars and do exploration, they're going to have to breathe. They can't breathe the atmosphere that's there, so we have to create oxygen. So now we're showing that we have a way to create oxygen so people can breathe on the surface. Okay? The other thing that most people, I don't even know if I'm supposed to say it, but who cares? I will. You guys there, hi, don't tell anybody. One of the things that we're doing, and you can't see it in here, underneath the vehicle, we're doing this technology demonstration. It's not been approved yet. It's not 100% that it's going to fly, but it is working. We're going to fly a helicopter. So underneath the vehicle, which most people don't know, they did a thing in Road and Track. Actually, underneath the rover, there lives this thing that we call the Mars helicopter. I think for a while it's called Leonardo. It's a little helicopter that we're going to put on the surface. It's going to fly up, and it's going to try to take images of the rover and then go off and take images. So we've actually done some testing. We've actually tested in a vacuum, not a vacuum, pure vacuum, but 7-torr CO2, which is the Mars environment, and it flies, and we have control over it. So we're really excited that it might get funded the rest of the way to actually fly, which is so cool. I'm very excited about it. I don't know. I'm just sort of that way. I'm going to leave you guys with a couple images that just blow me away from the surface of Mars. So this one, you guys see that star out there in the distance?
No. Yeah.
There's a star right there.
Oh, you make it much. Yeah.
That star from Mars would look a little blue. Anybody know what that star is? Yeah, it's Earth. And our camera on Curiosity is so good we can actually see the moon.
Oh, yeah, it is.
It's really, really hard. It's a little light from the projector, but it's really hard to see, right? Then I'm going to leave you guys with my favorite video. So this is my favorite video from the surface of Mars. This is the sun setting on Mars. And this was actually taken by the Spirit vehicle. It was taken January 24th of 2005, right? So maybe before most of you guys were born. But to me, I can't wait to have a human being tell us what it looks like to see the sunset on Mars. I think that would be just one of the most amazing conversations to have with an astronaut that's standing on the surface of Mars telling what that's like. I want to thank you guys for listening. I hope you guys had fun. We'll get a little bit of time for questions and answers. And I want to shout out, I'm going to go over here. I want to shout out the people that are on, the children at the hospitals that are on there. Alberta, Canada, the Alberta Children's that are on there. What else we got? We got Mount Sinai in New York City, and we got Cohen Children. So, hey guys, I hope you guys really enjoyed it. It's really been awesome having you guys doing the distance learning thing. And it's really awesome that you guys get to do this and you know, get well soon. Okay, so we're going to take a few questions. And when we're doing that, I'm gonna do something while we're gonna take a couple questions. You want to pick?
20 minutes for questions.
Yeah, you do it, because then I don't get in trouble.
Let's go all the way to the back in the blue hoodie.
Okay, blue hoodie. Stand up and project.
How big, like when the Mars, the rocket enters, that last stage before it like turns into a balloon, how big is that like place that holds everything?
So how big is the heat shield, more or less?
Yeah.
So the heat shield, so for Curiosity, the heat shield is 4.7 meters. And the reason it's 4.7 meters, so convert it later, but a meter is about 3 feet, right? So 3 times 4 is 12, plus another half, so it's like 15 feet in diameter. And the reason it's 15 feet in diameter is that's the biggest rocket that we have, right? The other thing is that's the biggest thing that fits in our chamber to test it. Right? It won't fit in the door, so we have to make it a little bit smaller. For Spirit and Opportunity is a little bit smaller. I think it was 3.5, so it's a little bit smaller. Okay, so it's pretty big. It's pretty big, about 15 feet in diameter, and it's about 6 meters tall, 6 to 7 meters tall. That's the whole entry vehicle. Okay, great question. While I'm doing that, I'm gonna hold up the wheel. So here's the wheel from the vehicle. So this was the wheel that was on the Spirit Rover at one point in time. Remember, I showed you guys doing the testing and driving it. So this was on Spirit Rover. This is serial number 13, right? And so we're superstitious, just like everybody else, so we don't fly serial number 13. So it gets to sit in my office. So I get to bring it out and show everybody a wheel. I have another wheel here. We'll get to that. Yes, young lady, why don't you do the next one?
How big is the little helicopter?
How big is the helicopter?
Yeah.
So the helicopter is actually really small. The blades are really big. I don't know exact dimensions. I don't know if I can really tell you the exact dimensions at this point, but the body's about this big, square, and the blades are about that big, right? Because we need to move a lot more air than we do here on Earth, right? Because it's 1/100th, the atmosphere is 1/100th ours, so we have to move a lot more air. We have to spin really fast. So it's not like the drones that you see that fly around. My wife has one, but it's not like that. So the blades are like this, and there's 4 of them. This is more of a bi-blade helicopter, so we get a little bit more control. But it looks just like it's like a square box with 2 blades. Look it up on the internet, see if you can see it. Let's go way up in the back in the middle. Yeah. Stand up. I can't. You're gonna have to project.
What?
No, this one over here.
I was wondering, when is there going to be a manned mission to Mars, or when is there plans to be a manned mission to Mars?
Yeah, when is there going to be a manned mission to Mars, and when there's planned for a manned mission to Mars? There's people from the Buzz Aldrin group here. I wonder if they want to push that. Look, it can't happen fast enough for me. In reality, all of the engineering that we would need to do is done. The thing that we don't have is a launch vehicle. Today, SpaceX is testing a launch vehicle. Hopefully they'll get to launch it. That might have the capability of doing it. NASA is building a launch vehicle too called SLS that has the capability to do it. So we need a heavier launch vehicle than what we have now to get somebody to Mars. That's really one of the challenges. The other challenge is keeping a human being alive through that time period to get to the surface of Mars. Now the last thing, which is interesting, I'm doing this because that light's right in my eyes. The last thing that is interesting is that we can't necessarily today land a human being the same way we can land a rover, right? So as we hit the upper atmosphere, the rover is experiencing 14 to 14.5 Gs. 14.5 times the gravitational force of Earth. I'll do some real quick numbers for you. Most roller coasters, how many of you guys like roller coasters? Okay, most roller coasters are designed to work around 4 Gs. 4 Gs is about the limit for most human beings where they'll pass out. Astronauts are trained, right, and people with G suits can take about 12 Gs for about half a millisecond to a second, right? So period of time, very small. When we hit the upper atmosphere at 14.5 Gs, that lasts for about 30 to 40 seconds, maybe a little bit longer. We would actually pull your brain through the stem of your spine. Right? In other words, we would liquefy your brain. We cannot stop a human being there. I'm being a little gross, but that's why we cannot stop a human being that way. We have to come in a different direction. Right? We have to do more like what we did with the Gemini and the Apollo. Right? So we have to go a little bit slower. It takes a little bit longer to get to Mars. Some of the trajectories that we have are about 2 years. Right? So instead of 8 months to get to the surface of Mars, it would take us 2 years to get to Mars. We could stay on Mars for 2 weeks or 2 years, and then we can come back. Okay? So other than that, soon. No, the reality is that it depends on what the plans are, and it depends on Congress and how much they fund in terms of exploration for human beings. Our president has stated in public that he would like us to go back to the moon and then on to Mars. If that program happens, I would say within 12 years, plus or minus, we will be able to send somebody, we'll have somebody ready to go to Mars. Now, that's not saying what SpaceX is doing. If SpaceX does that, it could happen a lot faster. A lot faster. In fact, they had the plan to do that, what was it, 2 years ago? Mars 1 was 2 years ago approximately, right? And so that was a 511-day voyage. They weren't going to land, but they were going to go around Mars. So hopefully very soon. We normally say somewhere around the kids, students that are like 3rd or 4th grade. That's about the age that we think we'll have. They'll be being astronauts, becoming astronauts. About the age, that time frame is about what's going to stand on Mars. Okay, 2 more. Let's see. Yes, young lady here in the pink.
If we ever do a manned mission, if we find life, how do we tell the evidence back to NASA of what's still being on Mars?
Okay, so if we have a manned mission to Mars and we find life, how would we actually get that information back to Earth so that we would understand? Well, really, we're going to try to do that long before we get a human being there. Right? So right now with Mars 2020, one of the things that it does is it actually stores samples, and hopefully we can get some samples that might have life. And then the next mission that we're going to talk about, maybe, is called Mars Sample Return. We would go, we'd bring those samples, we'd put them inside the vehicle, and we'd send them back to Earth. And that's probably within the next 5 to 7 years. Right? So we'll do a sample return. But life is a very difficult thing to define. I actually went to a talk by one of our geologists, and if you listen to that geologist on long scales, scales of 100 to 10,000 years, you would actually believe that rocks were alive. Right? Because they actually meet the definition that some definitions of the word life. Right? Now, biological life that reproduces, that actually, exposes, eats and then defecates and all that kind of stuff, that's a different definition. But it just depends on how you define life. Either way, we found water on Mars. Wherever we find water here on Earth, we find life. It's quite possible, even probable, that we'll find life on the surface of Mars. Okay. Young man. Why don't we use caterpillar tracks on rovers? A mobility question. Ooh, good question. All right. So, in World War II, they did lots and lots of testing on mobility. The reason we don't use tracks is the way to stop a tank. Right? I'll tell you guys. The way to stop a tank is you build a trench at the angle of repose. So if you take the angle of repose of dirt and you make a trench like this, the tank will drive in and never be able to get out. It can't even turn. Right? It's the Achilles heel of a tracked vehicle. Right? Wheeled vehicles don't have that problem. Right? And so there's some other issues, but that's really fundamentally why we don't use tracked vehicles. And tracked vehicles don't have fault tolerance. Opportunity, or I should say Spirit, lost one of its wheels, and we drug it. Opportunity has one of its wheels that doesn't turn very well, and we drag it, and it's not a problem, because we have 5 other ones that drive. If we had a track, it would be very difficult to do that. So some of it's about redundancy. Okay, let me do one right here in front, because he's had his arm up. I'm sorry, we're going to go ahead. What do I think is the most successful rover? I think they're all successful. And the reason I punt that answer and I don't give you one is that Spirit, we landed in a place that we didn't really know. It was able to tell us that there was water. It happened late in her life, but we were able to tell them. Opportunity landed in a parking lot, was able to tell there was water. We call her the good sister. Was able to tell there was water there within the first couple weeks, and then has lasted for 14 years. Curiosity goes to show that we could actually support biological life on the surface of Mars, and if life started, it would be able to be sustained. And it does that within its first sample. All of them have told us a different story of Mars, right? And all of them have filled in this unbelievable story about the history of what is Mars. I'm sorry I don't have time for everybody's questions. Thank you guys so much. Okay, go ahead. Shoot it. I gotta hear it. What's the difference between Martians and aliens? Well, aliens could be from anywhere and Martians would be from Mars. Thank you guys. I hope you had a good time. Really great to see you guys. Take care. Have a great rest of the day.